Alright, hi to the one or two people watching this. I'm going to be covering how to investigate or debug Python code using VS Code as my text editor. It is a really nice text editor that allows for some really interactive debugging sessions. So, without further ado, we can just look into one of the coding projects that I've been working on for a little while across multiple different behavioral tests that we're running, where we are essentially just taking in the behavioral data and using lots of other people's work to convert the ePrime data files to a tabular separated values file that we can actually use for processing down the line and to generate quality assurance images. So the things that I assume when you watch this video is that you know kind of the context of our coding project, at least a little bit, and the and I guess how you'd call the command. I can go through how we call the command right now, actually. So if we wanted to call this, it would just be ePrime convert and say help just to see what the command line options are. So we can see that we have a option to specify the root folder of a valid bids dataset. That's where we're going to output everything. We have a -r for Roger, so that's where all the ePrime data files are output. And we have a config, which is going to be directly passed into Taylor Salo's tool that actually does the heavy lifting of converting those relatively unformatted text files to a CSV file that we can actually manipulate and rename and make pretty figures with. Okay, so I just want you to get a look at those arguments since we'll be using those in VS Code. Now, the next thing that I'm not going to be covering is how to install VS Code. I think that it's pretty straightforward process, but yeah, if you have any problems, you can contact me. And now, if you want to start it via the terminal, you can just type in code and the directory that you want to start it in, which is going to be the current directory for me. So just code, period. Alright, and now I'll switch screens so you can see what I'm seeing. Alright. This is Visual Studio Code, just to get yourself oriented. We have two tabs open right now. One is the actual code file that we want to run, and another thing is called launch.json. And ePrime convert, this is the actual code that's been written and how we could interface it via the command line, but it might not necessarily look accessible or understandable. So the goal of this tutorial is to try to get it so that you can walk through a piece of code and hopefully understand it better using a debugger. What's really nice with VS Code is that they make it so much easier to see the context in which you see the code and the environment in which it's running, and just a way to manipulate with the variables, which you can use with a default Python debugger, but VS Code adds some extra nice features. So in order to understand how to get it set up so you can run some debugging, I'll go through just a little bit of orientation for VS Code just so you aren't completely confused. I guess one of the main I don't know, let's say features, or just one of the things to get to know about VS Code is along the left-hand side here. We have different areas in which we can interact with VS Code. So the top one's the Explorer, so this is how we can open up different files that we would want to deal with or that we would want to manipulate. So if I double click on ePrime Convert, if I closed this convert and open it again, now I can see it. So the File Explorer, just as it seems, it just lets you explore the files. Search will, I think this will search through all files that I have open. Yes, yeah, so it'll look in all these different files that are available within this directory for this particular phrase. So that is useful, nice, very nice for multiple file searching. It has its own GitHub integrations, which I don't leverage too often. There are a place to install extensions, which is going to be a prerequisite here, which I'll cover in just a minute. Then there's a Docker tab, which is also based off an extension, which can link to Docker Hub and all your local images that you have on your local machine, but we won't cover that for now. And I just installed this today, so I haven't really done a lot with this, but Git Lens, which is apparently a little bit more detail on the Git integration, so I can see who has done what on which lines and just have a much tighter control on source. Let's go back to extensions to see what you need installed in order to run this. So if I go to show installed extensions, I have a few, still not too many. What we need for this though is the Python extension, and that is the only one that's absolutely required. It should be pretty easy to find once you install VS Code. It should be the most popular extension for Python. Right now it has 32.6 million downloads. So once you install VS Code, you'll want to install this Python extension, and it will grant you access to so many good tools. All right, so once you're at that point, we can move on to the debugger. So click on the Debug tab, which I guess is also the shortcut, Control-Shift-D, so I'll try that, Control-Shift-D. Nice. Now with the debugger, you have the option to run with different types of debugging scenarios. So none of those truly fit the case that I wanted it to run with, so I had to define my own, which you can do, I'll just exit out of that, which you can do by hitting this gear box right here, and this is your configuration for testing, which for us, we're just going to use it as a learning tool as opposed for strictly testing. And what pops up is a bunch of options for different types of testing environments or debugging environments that we can make, but none of them do what we want them to do. So I inserted another configuration up here, and I called it run eprime_convert.py. And what it's going to do, I'm not going to cover these keywords too much. The type of configuration, it's a Python configuration. The request, I'm not going to go into that. The program is the actual file that we want to run. So within our workspace folder, and this is a reserved variable within VS Code called workspace folder, which is our current code folder that we're in. So just we specify the eprime convert file, we need to go to workspace folder /eprime_convert. And then the console that we selected was an integrated terminal. So integrated means within the VS Code text editor. And then I can specify args. So these are the actual arguments that you can pass into eprime convert. So what we showed on the terminal, remember that -r stood for raw. Then what I'm passing into raw is the directory that's one up from where I am, which is just the actual place where all the ePrime files are stored. I have a -b for the bids directory, and I'm just going to place that right where I am in a directory called bids, so just in my current directory, and then the config file is just going to be called a task.json file. I suppose I can cover the task.json really quick. All this really does is interacts with Taylor Silo's tool for his ePrime or convert ePrime package, and all I do is select which ones I which column headers or which things that will eventually become column headers, which features of the experiment do I want to track. And this will just come with the knowledge of the experiment. And the rest of this I won't go into. Not important for now. We'll step back to ePrime convert. Then we'll go down to the debug tab again. Alright, so then the general overview that I have everything that's relatively unorganized, and I apologize in advance for this code, but it works, and that's all I can say about it, is that it works for the situation that we're using then. Okay, so the brief overview is that we have all the imports at top. We separate the session dict to say that file names that contain the letter A, which will become apparent in the near future, correspond to the pre-session, and file names with the letter B correspond to the post-session. Then this piece of code is heavily borrowed from the fmri prep architecture. Copy ePrime files just to make sure I don't rewrite or overwrite the original files. I just copy them to a working directory. And this is the main piece of code, or the main block of code that's being written and being executed. So ideally this should be all turned up into little bite-sized functions, but now it's just a long spaghetti mess. So that is what I have to deal with. Alright. Those little comments aren't relevant anymore. And at the very bottom here, we see this somewhat, I said archaic the other day, but that's not what I wanted to say. Esoteric was the word I was looking for, esoteric. This esoteric statement in which which basically at a high level says if we call this function on the command line like we did by specifying ePrime underscore convert.py with those options, by default it will run the main function. Otherwise, if we try to use this as a module, as in if we try to import this file somewhere else, then it won't run the main function. So that's just a way to get the functionality of a command line script in a file like this, and to have it also be available as I guess a simple library if that was ever going to be useful. Alright, so I'm done explaining the main overview of the code, and now we're going to step into the debugging session very shortly. Just want to cover one more thing, or a few more things, just to get an overview of the actual debug window that we have over here. Okay. So variables will track all the current variables that are defined in the session. I guess I am not going to cover watch right now since that's not important for our current tutorial. And then breakpoints is going to be important, so I'm going to remove all breakpoints for now. this is going to determine when we step into the code and allow the debugger to pick up. So for this session, I am going to have a breakpoint right inside the definition of main. So the debugger will pick up right as it hits this line. Okay. So now, as defined in our launch.json file, I have the run eprimeconvert.py configuration, and that's faithfully reproduced up here in this little debug taskbar. So now I'm ready to hit start debugging. So I'll start running it, and eventually it will pass control back to me, and it will say, okay, now we're at the place where we want to get parser and parse args. So as I've said, everything, I guess I haven't said in this video, but I say a lot, everything in Python is an object, and many operations return an object. So get parser is a definition that is up here, and it returns an object named parser, and then that object has a method called parse args, which then returns another object that we define as ops. So let's see if we can't take a look at that. And now that we're in the debugging session, we can also see that we have access to a few commands in this little taskbar here that we can move around if we want to. At least a little bit. We can move it around a little bit. Okay. So step over essentially means move on to the next line. Step in means we want to go into the next level of what we call the call stack and to see what is actually going on in that function or whatever is going on if there's a function call in that line. And step out means we want to move up a level in the call stack again. And trying to think of a simple way to call stack is essentially the current set of things that we need to do in the program. So right now, if I wanted to step in, I wanted to see what's actually going on with the get parser. So I can say step into, and that will drop me in the get parser function. So now I can physically go through each line. This shouldn't have anything, yeah. Now I can physically go through each line and see what a parser is. Okay, so a parser looks like an object that has quite a few attributes to it, but this is something that you can manipulate, and I can also type it down here. So what is my parser? So again, it shows off all the same information just in the debug console that we have down here. I can make bigger or smaller. So again, vscode is really nice because it allows you to really step in and really interrogate what's going on inside your code. So I'll step over. So we define all the options here. Okay. So I haven't actually investigated where this stuff is located. So I got option string action. Right, nice. So it looks like inside, okay, let's see. So inside parser, there is an attribute called option string action. Okay, so let's see what happens when I type this in the debug console. So parser dot option string action. That should be a dictionary. All right. Nice. And so I can just investigate how everything's actually stored and how everything actually works. Right now, some of this can just be an exercise in curiosity than rather necessity. But whatever gets past, whatever helps you learn. Now I will step over, and we're passed back into the main function. So we came out of the get parser function. And now we can see what is ops. So I can type in ops here. Okay, and it looks like it's some type of. Let's see if we can type in type of ops. So it's an argparse.namespace object. But what that means to us and how we can manipulate it is that we can do ops.bids, ops.config, ops.rudder, and that will give us all the options that we specified in the command line, or in this case in the launch.json file, and give them or hand them to us. All right. Now the bidsdir is going to be equal to os.path.abspath. So os is another library or package that we imported from up here, and os we can consider an object which has the attribute path, which then has the function abspath, which we can pass in our variable ops that was defined up here, and ops has the attribute bids. So we just type in ops.bids, we should just get the string bids. So, and that's what we passed in to the function to begin with. So all of that is expected. And let's just see what happens. Step over. Bidsdir. Now it has the fully qualified path, or the absolute path, to the bids directory. And this command will make sure that that is a directory. So if I do os.path.bidsdir for bidsdir, let's say that is false. Now let's see what happens when we run this command. And I run that again. Now it's true, so this command made that directory. Now we'll define a couple directories within that bidsdir where we're going to store the source data and output the derivatives for the QA check that we do. Now we'll step over, and we can look and see, oh, just a string that points to that particular directory, same for source data. And now we're going to make sure that both of those directories exist, just the same method that we use for the bidsdir. All right. So now we're hitting into the first thing that has a little bit of complicated logic that probably doesn't need to be as complicated. So step over. So if ops.rudder exists, so ops.rudder, which indeed it does, it's pointing just one directory up, that's what the double dot means. We are going to step say the raw dir is the absolute path. So step over that line, and we see that indeed is path to the folders that we want. Now step into this for loop in which we have task type and session dict.keys. So the session dict was defined up here. So we're looking in, and the keys are A and B. So my guess for first task type that I call in session dict is going to be A. So if I do session dict got keys, what's going on there? So it's the keys A and B. Now if I type in task type, that is A, and we can see it up here in the variable viewer as well. And then for sexing, chord female, chord male, which those correspond to, I'll switch screens here just so you can see what that refers to. That refers to chord female A, chord female B, chord male A, chord male B, those four. Those are the four directories that actually contain all of the eData files and the text files that go with them. So if I go into chord female A, for example, we see all of these files that are text and eDat files. Okay. Now let's hop back over to the code. So for sexing chord female and chord male, so I guess what we're seeing here is that we're missing A and B on the suffix of each of these, but we see that A and B is located in task type. Oh, that's cool. I didn't know if you hovered over it, it'll actually tell you what the contents of that variable is. I wonder if it'll tell me for this. Oh, well, all right. Like I said, I haven't been using this for long, and it's just getting cooler and cooler the more I look at it. Now the raw file dir, so we're gonna have a particular file directory that we want to use, which will be the raw directory, which is everything up to byte extend chord, and then plus sex, which is chord female, and A. So chord female A will be the first iteration of this directory. Then it will run the copy e prime files command, and that command returns the number of files copied. So we can just step into this for the first iteration to see what it's doing. And you can see that source and dest are the arguments that it takes, and those are defined. Source is chord female A, and dest is the source data chord. So we'll step for type in types, which we have defined as e.to and anything.text. We will have this list that we have called raw files, and we'll extend that list with all the files that we need. So for the first iteration, we're going to be working with edat files. Now we can see in raw files we have it matching all of the edat files, and now we're going to do the same thing for text files. Over. Now we should have a bunch of text files. Nice. Okay. Now we'll move over, saying copied files equals 0, so we haven't copied these files yet. Then we'll do for file in each of these, or each of these files that are in raw files. We'll specify the name of an out file. Then we'll ask if this out file exists. So does this out file already exist in that predefined directory? Then if it does not, we will copy it using the shootil.copy command. Boom, boom. And this will go through all of the iterations. So you can see that copied files is iterating up. This file variable is updating for each iteration of the for loop. This will keep going until I've done it for everything. Let's say we are done with that, and we just want to step back out. And this will take me, where will that take me? Okay, that'll take me back here. Now files that are copied are equal to 72. Since that is what the function above returned, the number, or what it returns on the function side. What it actually does, I guess what we care about is the side effect of it actually copying the files over. So we'll keep going through here. So we iterated over A and B for chord female and chord male, so that means we copied all the pre's and posts for both the chord female and the chord male task. Then we'll print out how many files we copied, which will be output here. Now, we're moving on and moving down the code line. Now we didn't specify ops.participant label, so this is equal to none. That means all the participants we want are going to be defined down here. And this code currently isn't functional because participant label up here is assumed to be a string, but our what we'll see down here, or is it's supposed to be a string or a list, but what we'll see down here, I guess it should be a list. This should always be a list. But we'll see down here, it's going to be a list of dictionaries as opposed to a list of strings. So we'll see that happen as we go through the participant files, which is going to match all of the files in that source directory, so all the place that we just copied all those files to. Oh yes, we can see it. So in that source data chord. We're going to look for everything that looks like pre_chord balanced _asterisk. Step over that and just say, what is participant files? That's going to be a big long list. We can look in here, it's a big long list. Now let's see, we initialize participants as an empty list. Then for participant file in participant files, so participant file will take on each of the values for each of the strings within participant files eventually. First one, say, is female 21, female A, then 2156. Nice, their lucky day there first. We'll step over, sub. I guess I did skip over this whole mess up here. But suffice it to say what is necessary. This is a regular expression. I will not cover how regular expressions work, but they are very useful and can let you select and manipulate or just let you find file names and organize them in a very useful manner if you can use them correctly. So I highly recommend learning how to use regular expressions. And I guess another benefit is that once you learn the general syntax of regular expressions, they can apply it to pretty much any programming language you use. They all kind of use a similar regular expression syntax. It's kind of the, I guess it's kind of a programming language that's embedded in all other programming languages. So once you learn it, you know it. There might be some subtle differences between different packages, but it is awesome to know on its own. And to know, I guess it would also be important to point out that it is different from globbing. I always call globbing like dumb regular expressions, or I guess like simple regular expressions. It follows a slightly different syntax, as we can just see here, where the period asterisk represents where the period represents any character, and then the asterisk represents any number of times, which means it modifies the character right before it. So that means this can match any character any number of times, whereas in the glob statement, the asterisk just means any character any number of times just by itself. It doesn't need a modifier. If this was interpreted as a regular expression, this would mean an underscore any number of times. And I should note that any number of times with the asterisk at least means 0 or more. So if this was a regular expression, it would be an underscore 0 or more times. Alright, I've already talked more about regular expressions than I wanted to, but the important bit that we're going to cover here is a concept called capture groups, which are things within these parens here. And basically, what these capture groups allow us to do is reference them after we match the whatever's in the context of the string that we're searching, which for our purposes is going to be this participant file here. So this participant file, we are going to be looking for what's inside this file name. And I had the period asterisk because I do not care how we get to this file. All I care about is at the base of this file. I do not care about any of the directory information, so I don't care what the directories are called. Okay, so with the capture group, I will capture the sex ID, which corresponds to male or female in the file name. Then the session ID, which comes right after, is then either A or B. And after that, there's a dash, then the sub ID is going to be a 4-digit number. And finally, this isn't super important, but I'm also capturing the file number, which I guess if you're familiar with bids formatting, or bids concepts, this would be kind of analogous to a run as opposed to a session. So a run being, in this case, would just mean the task didn't work the first time or something along those lines. Okay, so now with that long explanation out of the way, now I can explain this sub_source. So when I defined this regular expression here, I can use it to search the participant file for anything that matches this regular expression to see if it matches this particular pattern that I set forth. And I set that to the variable sub source. Okay, so if I run this, I will get sub source, which is an object. If I can do type sub source, it is a class of the underscore SRE match, or SRE underscore SRE dot SRE underscore match. Okay. Then if I look inside it in my little variable explorer up here, I can see that it has different attributes. Has the regular expression that I defined, has the group index, so text ID, sesh ID, all of those wonderful things. And I think, yeah, and this is where the exact characters are matching, or the start and end indices of those characters for each of those groups. Oh, and I think that you can edit everything. So I guess if you want to get interesting behavior, you can edit the variables as you go along, which is great when it's broken and you need to debug something. But as a learning exercise, yeah, it might be useful to break things too. So you can break things to your heart's content. You just might need to restart the debugger, which should be fine, in case you can't figure out how to get things working again in your current session. Okay, so subsource is not none. So this will be none if the sub expression doesn't find anything. Then I'm going to ask for the subdict. Just going to be those groups that I defined. Getting lots of variables now. The subdict, so the file num is 1, sesh ID is A, sex ID is female, sub ID is 2156. So it matched everything exactly how we wanted. Now we're going to use this participants list, and we're going to append this dictionary to that list. Okay. Now we have one person. We can go through this again, and again. If I can use until. No. Is this not what I wanted? Maybe I can't use until here. Maybe unt. No. So maybe I can set up another bug point right here. Maybe I cannot. Go. I hit function F9 to set another debug point. And now I'll just hit continue until I reach that point. Okay, so that's so I don't have to click through the entire for loop. But now we can see that our participants list is full of dictionaries, and those dictionaries are full of the 4 keys that we defined in our regular expression up here for file num, sesh ID, sex ID, sub ID. We'll step over because we didn't define ops.sesh label, and if I type it down here, ops.session label none. So by default, if something is none, if will interpret that to be false. So it'll move directly to the else. So we want to use both sessions A and B to iterate over. All right. Now this is the chord template file name. So this will be a string that we eventually populate with sex/sub filen dot the extension, which will either be text or edat file. So now the goal of this block of code, if this block of code up here was just to grab the files, just to make sure we wanted to filter all the text files to the files that we wanted to use, then this block of code is going to organize those text files into another dictionary that we will use sub-id to help organize. Okay, so hope everyone's still doing all right as we continue along. All right. That's going to be our template string that we're going to fill over with the relevant information. You can see it looks very similar to our regular expression because it's exactly trying to match those file names again. And I guess before I continue, I will emphasize again, I don't think that this is necessarily best practice. This is just what I did to get the code to work. Okay, so now we have a chord dict, which is going to collect all of the files, and it will be like a super embedded dictionary, which is hard to explain. So we'll just take a look and say, like, this is a dictionary that contains a dictionary that contains a dictionary. And it'll make sense once we get to the deepest level. Okay. Now we have chord dict, which is currently a dictionary that contains the key 2156. And the value for that key is a dictionary that contains the key A. And the value of A is and the value of A is a dictionary that contains female or male. Sorry, I guess right now it's just female. And then female as a key contains a dictionary that has edat and text. So this is just going to, this overarching structure is just going to make sure that all of the information is organized in such a way that I can query, okay, I want data from subject 2156, I want their pre-session, I want them from female. And the rest of this code is basically, well, here. The rest of this code is basically just to make sure that we know where the edat file is and that the text file exists, which probably being a little bit too paranoid that the text file should exist, since it by definition from our collection procedure up here, the text file should exist. All right. But anyways, let's go through. Our edat file is now a string in which we've replaced all of these placeholders with their relevant parts. Oh, is it actually? Okay, no. Okay, never mind. Sex is chord male. Sesh. How does it know? Maybe it's just guessing. Okay. Okay, so we'll check to make sure all the information exists. Gonna check the text file. The text file should exist. All right. then we'll see what we get. Okay, so now we're adding a new key, which is B. So I'll just run through this a few times so you can get an idea of what the thing look like as we iterate over everything, or what the chord dictionary will look like as we iterate a few loops. All right. So now we have a few fully fleshed out subjects. We got session A and B for 256. We have female. I guess we just have female. Okay. And for B, we don't have anything yet, or we just don't have anything. Okay, let's check for 1. We have A, female, B, female. Guess the males haven't been populated yet. Hehe. Guess there's a joke in there somewhere, but I'm a little bit too tired now to come up with one. Okay. Okay, now I just need to find the end of the loop. Or no, I just need to specify that I want to set a debug point here and then continue. Alrighty. And now anything that should be populated that is there should be populated inside this super embedded dictionary. So we got male, male, female, okay. Female. Oh, did I write this wrong? Maybe this debugging session will point out a mistake. In session. A or B. Maybe subjects for just counterbalance. But they only had male or female. They didn't do both. Alright, now I'm actually going to check the actual files to see what's going on here. I'll switch the screen so you can see what I'm doing. Okay. 2009 and female. Okay. Okay, looks like it was counterbalanced, but there's not data. Did one, you didn't do the other. Did male, you didn't do female, and vice versa. Okay. So things are not wrong. I'll switch back this screen, and we'll continue on our happy way. Let's see. Now we're going to do for participant in chord underscore dict dot keys. So now chord underscore dict keys is a bunch of strings. Step into that. We didn't specify a prefix that we wanted to add to the participant, so now we are going to iterate over session for this particular participant. And then finally for task, which is it's going to be male or female. That's what that will resolve to. So that one's female. All right. And we go into a folder. Well, we have behavioral folder. I guess it's just kind of hanging out here as a little variable definition. Not that useful. And not that useful of a name. But anyways, have it. I don't even use it. I don't know if I even use that variable. But anyways, it's just a variable that's hanging out. Probably should be cleaned up. I have a work file, which uses a template and os.path.join. But we just look at what it is. We are getting a busy variable panel here. Oh, actually, I guess I haven't defined it yet. Now it should exist. So you can see it's this big long directory, source data cord, work, da 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 da, and eventually be CSV. And that output will be from Taylor Sales program, which we call right here. So a bunch of work is written into here, and I'm not going to step into it just for the sake of time since we're already going pretty long. But regardless to say, some magic happens, and we come out with a CSV that we can work with. Ta-da! Now we can make a data frame out of that, which I unimaginably called DF, short for data frame. And now what I've learned is that I cannot actually click on this, otherwise the debugger will crash. So I'm going to be careful here about what I do with touching the data frame. But anyways, you can also see these steps in the Python notebook and the different operations that I do to the data frame. So let's explain at a high level here. So there's a for_if column which explains the frequency of a stimulus, whether it's supposed to be frequent or infrequent. And now I'm just naming it to reflect that a little bit more explicitly. And we have in place here, which means do not return a new copy of the data frame, or in particular this this column. Just write it in the same memory location. So I suppose it's kind of memory efficient and means I don't have to redefine df to point to a new data frame every time I do an operation. Now I've redefined df. I guess not really redefined, but modified it. Now in the CSV, there's a couple empty rows in there. So now I want to drop all of those. And now I'm going to rename all of the columns that were pulled out from that edata file. I guess like the text file, to be more precise, that goes alongside the edata file. And I will name those into things that I feel are more clear. Rename, 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 rename. And again, in place. And now I do the little bit more long form reassignment where I say the left correct. Got some nice warnings there. Where I want this ones and zeros, which is currently a bunch of floats. I want that to be an integer. Same for right correct, so they had to press a button with their left and right hand, so they could either be correct or incorrect with their left or right hand. And I also want to treat block as an integer right now. It's being treated as a float since they had to do several, what we would say, blocks of the task. I guess a block, for those that don't know, is just a series of trials that are separated by some type of rest period or some type of instruction period. And now we are redefining the response time. BIDS requires it to be in the unit of seconds, whereas in the edat file and the adjoining text file, they are represented in milliseconds. So I just need to divide the milliseconds by 1,000 and I get seconds. And here, both correct means they actually got the entire trial correct, so both their left hand and right hand had to press the correct button. And I guess the one way to think of when they completed the trial is just which hand pressed last. So we can look at response time left and response time right and see which one is the most, and then we'll assign that to the response time slowest. And so the purpose of all these operations is just to organize the data frame into a way that will hopefully be analyzable and summarizable by us in the future. Now we make another template file for how we're going to name the output tabular separated values file from our data frame. Then we try to make that, make the directory, make sure that the directory towards that file exists. Then finally, this command physically writes out the file. Ba-doop. Now we'll do some quality assurance. So right now we're just like naming the output JSON files and what eventually will be the figure file that we make. Then the JSON file that we're going to make and it's going to go into the derivatives directory is just going to contain some basic information just to perhaps programmatically filter out subjects that we don't want anymore in case that is something useful. And then finally, we make a figure. And I don't know how much detail I'm actually going to go into about making this figure. Probably not a lot, except that it just took a little while to make it because it was somewhat complicated to get everything working the way that I wanted it to work. So figure building, I guess I should say, should be done within an interactive environment. So something like a Jupyter Notebook, probably not vscode, in order to get that nice feedback of what the image looks like and how you can iterate and build on top of that image. So this is probably, or currently this is not the environment that I would use. But the high level explanation of the figure is that I wanted a swarm plot, which is just a representation of all the individual trial points, which will indicate whether the subject got the answer right or wrong, and the slowest reaction time for that between the two hands for that trial. And it'll be split across blocks. So we'll have one for block 1 all the way to block 10. We'll have a new graph, and there's just different things to make the graph look taller, which is the aspect ratio, and the facet Args helps squish the plots together so that they appear closer together. All right, And now I mess with the legend a bit so that it tells me something a little bit more informative than um, 0, 1. I want 0 to be incorrect and I want 1 to be correct. That's easily interpretable. And now I also wanted to add a box plot to each of the swarm plots that I had. Now the box plot will allow you to kind of quickly pull out like what the mean of all the dots are. Since a swarm plot's nice just to get an actual physical idea of being able to see all the data, but it doesn't really give you a summary of what the data look like. And with this, I look through, take the average of all the response times that are not 0, so just not the missed responses, but anything that they actually did have a response for, whether it's incorrect or correct, they have that'll go into the mean and the definitions of the interquartile ranges of the box plot. And I have a bunch of options here for coloring and how skinny I want them to look, and then whether or not I want to show the outliers. I did not. Then some other formatting. Okay, and I think from here I can just hit continue and it will just do all the rest for me. At least for that participant. Okay. Now I'm going to show you an example of one of the images that was just made, just so that you have something to say, oh, why did I sit through this freaking hour-long video? I'll show you something to take away. Alright, now I just need to Windows one more time so you can see the output of that. I just need to figure out which window that is. Not that one. That. Oh, that's the. Oh, come on. Please let me show you the image. Okay, well, I guess if I can't figure it out soon, I will just say I've been defeated. But, anyways, the image is, looks nice-ish. I wish you, I don't think I'll be able to figure this out in time. That should be shown. Okay. Try one more thing, maybe if I open it with Firefox. Maybe it'll open then. Maybe you'll be able to see it. If that's an accepted Actually, maybe I just need to go back. Oh, there we go. Okay. So, okay. Yeah, so this is the output. So eventually you can see the general pattern of all the individual dots, as well as try to get a general idea of the mean. Okay, thank you for your patience. That took a little bit longer than I expected to just show you a simple image. I'll hop back over to Visual Studio Code. All right, then I'll review what we learned here. That one, Visual Studio Code is an awesome tool, and I'm not paid to say that, but it's just my opinion right now, and I think it's really useful to understand the code that you're working with and to be productive with your writing, with your code writing. So I highly recommend to check out this tool. Okay, so first thing we learned, vscode, download it, use it. Second thing we learned, install the extension for Python. When you install vscode, that will make your life even more productive and useful. I think I have one for R too, but when you're writing in Python, use this Python extension. Now I'm curious if there's an R one. But use the Python one if you're ever writing in Python. Okay. Third thing we learned is this debugging panel, which we can use either for its purpose for debugging or just for learning how things work, which is a very good use of a debugger, I think, just for understanding things. And just a little bit of extra configuration to make sure that we run what we expect for our particular debugging application for our learning session. We have this launch.json file. And we learned, number 4, just hopefully at least the general organization of this code and how it functions, and hopefully if you have further questions you can install VS Code and you can clone this Git repository, and then you can just investigate it yourself. Alright, and I think with that I'm going to call it the end of this video, and I think I covered everything I wanted to cover. So thank you for sticking with me for this long, if you stuck with me for this long. And have a great day, night, whatever time that you're listening. And I hope that you don't mind, you didn't mind having my face in the corner that probably looked super bored out of its mind, or like not with it. I'm not bored. I just perpetually look that way sometimes when I'm been talking for a while. All right, well, thanks for sticking in. Have a good night. Yeah.